Okay, so here we go with the last lesson of this unit, and we're going to be talking about area of similar figures. And so just think back to what similarity means. But here we're just going to start with these two rectangles, and we're going to find the area and the perimeter of both the rectangles. So if you look at this 8 by 4, so area would equal 8 times 4, so the area would be 32. And then the perimeter, if you have 8, 4, 8, and 4, if you add all those up, you get 24. And if we're talking about area, obviously that's units squared, and perimeter would just be units. Okay, and so what we're going to be talking about today is dimensional change. And so if, let's say, both dimensions are twice as long, or 3 times as long, 4 times as long, or 20 times as long, or whatever, how you can figure out the new ratio of the perimeter or of the area. So, and so our original area, that's going to be the same all the way down, right? Okay, so our original area is 32. If both dimensions change, and so if it's twice as long, okay, so what I'm going to start doing is I'm going to say, okay, if it's twice as long, that means my scale factor is 2. Okay, 2 to 1. And I'm just doing this right now because it's going to help you later. But if it's twice as long, what's going to happen is it's going to be, your new area is going to be 128. Because what you would do is 16 times 8, which would get you 128. And so if you take the new ratio, okay, the new area to the old area. Okay, so if we do 128 over 32, so that's taking the new area and putting it over the old area, then the ratio of the areas is 4 to 1. So notice that the ratio of the dimensions is 2 to 1, but the area of the ratio area is going to be 4 to 1. Okay, that's going to be really important. Okay, so now let's say we look at 3 times as long. So if the dimensions are 3 to 1, so that's the original ratio of the dimensions. If we do all the math, the new area would be 288. Okay, so if you were to take the new area, which is 288, and divide it by the old area, which is 32, you would see that the ratio of the areas is 9 to 1. Okay, so now if we had 4 times as long, okay, so the dimensions are 4 times as long, so that would be 4 to 1. I'm not going to give you the new area here, but your new area ratio would be 16 to 1. And then if it's 5 times as long, so that would be 5 to 1. Then your area ratio would be 25 to 1. So you're going to start to see a pattern here. And we'll come back and talk about it here a little bit more in a minute. But notice whatever is happening to the dimensions. So when it was twice as long, if you square that, that's what the new ratio is. Okay, so if you square 2, it's 4. So now it's 4 to 1. If you take 3 times as long and you square that, that's 9. If you take 4 times as long and you square it, that's 16. And if you take 5 times as long and you square it, that's 25. Okay, so whatever is happening to the dimensions, if you're now going to compare new area, you're going to square that ratio. Okay, now when we talk about perimeter, perimeter is a little bit easier because it's going to be the same across the board. So our original perimeter was 24. So if you change both dimensions, and if it's now twice as long, so the original ratio of the dimensions is twice as long, our perimeter is 48. So if you took 8 and 4 and you doubled them, your new perimeter would be 48. And so our new perimeter, so 48 over our old perimeter is 24, is just 2 to 1. Okay, if it ends up being 3 times as long, so our dimensions are basically tripling, then your new perimeter would be 72. And your new ratio perimeter is still 3 to 1. Okay, that's not changing. okay, if it's 4 times as long. So our dimensions were 4-to-1 ratio. Your new perimeter is 96, and your ratio of perimeters is 4-to-1. So again, it didn't change. And then 5 times as long, that would be 5-to-1. Your new perimeter would be 120, and your perimeter ratio is 25-to-1. Not 25-to-1, I don't know why I just said that. 5-to-1. Okay, so with perimeter, think about how you measure perimeter. Those are just in units. Okay, so whatever units are here, so whatever the ratio is here, that's going to be the same ratio over here with your new perimeter. Now going back to area, think about what we say for units in area. We say units squared. Okay, well for our new area, that's what we have to do to the ratio. We had to square it. Okay, so units is going to be the same ratio for perimeter. For area, you're going to have to square it because that's units squared. That's just kind of a way that helps me remember. So it'll make more sense when we actually do these problems. Okay, and so that's basically what this table up at the top here is saying. So whatever change in dimensions, if it's multiplied by A, so it could be multiplied by 2, then your perimeter is also going to be multiplied by 2, and your area would be multiplied by 2 squared. That's what I just said on the last slide. All right, so now just looking at some examples the rest of the way. So the area of a triangle is 36 square millimeters. Suppose the dimensions were doubled. What is the new area? So you always want to identify what is happening to the dimensions. Okay, and I'm going to tell you the way that I do this. You may find a better way, but this is the way that I do it. So I always identify my original scale factor. So what is happening to our dimensions? Our dimensions are being doubled. Okay, so that's a scale factor of 2. Okay, so if it is a scale factor of 2, and we're talking about what is the new area, area are units that are squared. So in this case, millimeters squared. So I'm going to take my original scale factor and I'm going to square it. So now my area scale factors are 4-to-1. Okay? And so I am now going to set up a proportion. And really, you could get this without doing a proportion. But I'm just going to do it so I can show you another way. Because you can probably figure out already that we need to take this area that we were given and we need to multiply it by 4. And that is what we're going to have to do. But I'm going to show you just a way to set up a simple proportion. So I'm going to say I've got my old and I've got my new. This is probably going to seem a little elementary, but that's okay. So the dimensions were doubled, okay? And so what happened was our original, okay, this is getting bigger. So if this is doubled, that's like 4-to-1, okay? So 4-to-1. 4 is going to be my new, okay, because it's getting bigger, and 1's going to be my old, okay? And then I've got the area of the triangle. That's the old triangle is 36, and I need to figure out the new triangle. And so if you cross and multiply here, you get x as 144. And that would be millimeters squared. Okay, so again, could I have done that without setting a proportion? Yes, but sometimes it just makes sense too. So number 2, if the perimeter, notice we're talking perimeter here, is 36 and the dimensions are doubled, what is the new perimeter? Okay, so again, you always want to identify your original scale factor. So here our original scale factor again is 2. Since I'm talking about perimeter and that's just in units, then I'm not going to square it like I did on the last one. This is just going to be the same scale factor. So if the dimensions are being doubled, then our perimeter is being doubled. So our perimeter would just be 72 units. If you want to do a simple proportion here, again, you can just think about your old and your new triangle. And so if it's being doubled, okay, that's our new one is being doubled. Okay, and then I would put my old perimeter up top, So 36 over x, and if you cross multiply, you get x equals 72. Number 3, the triangles are similar. Find their side ratio, their perimeter ratio, and their area ratio. So notice here it's not actually asking you to find a new area or find a new perimeter. It's just asking you for the ratio. Okay, and so you can see here, we're going to get the ratio from just whatever's on their sides. So the side ratio is 2 to 5. Okay, which means the perimeter ratio, if we're talking perimeter is just in units. And so units don't just have a 1 on them, exponent of 1. And so our perimeter ratio is just the same. So it's also 2 to 5. Your area ratio, when you think of area, that's in units squared, which means we need to square both of those numbers, and that'll get us our area ratio. So our area ratio here is 4 to 25. Okay, number 4. In example 3, if the area of the larger triangle is 30, use a proportion to find the smaller triangle's area. Okay, so what we're going to use, we already found our new, our area ratio. We figured it as being 4 to 25. This is where the proportions kind of come in handy when we don't have really easy numbers to work with. And so this is my old, and this is my new. So the old area is 30. Use a proportion to, sorry, I just put that 30 in the wrong place. X-nay that. So use a proportion to find the smaller triangle's area. Okay, well, which one of these numbers is going to be the smaller? That would be the 4. So that's where I'm going to put X, and then I'm going to put 30 here. And this is really easy. Like, if you were to put X in the wrong place and you got a number, that number wouldn't make sense because your number would be bigger than 30, and they're telling you that the larger triangle is 30. And so if you cross multiply here, you end up getting X as 4.8. And that's area, so that is units squared. I don't think they gave us units. Okay, number 5. So if two pentagons' area ratio, now notice here they're giving us the ratio, is 36 to 9, then find their side ratios. Okay, so 36 to 9. Okay, think about how that area ratio was made. That area ratio was made by squaring the side ratios. Okay, so if the original numbers were squared to get to that ratio, then that means I need to take the square root to undo the ratio. And so that means the original ratio would have been 6 to 3, but we need to always simplify this. And so if I simplify it, that would be 2 to 1. Okay, number 6. If two squares have a side ratio of 2 to 3, so that's the original ratio, find their perimeter ratio and their area ratio. So again, perimeter ratio is just going to be the same as the ratio of the sides. So that's going to be 2 to 3. Okay, and the area ratio, I'm going to take that original ratio and I'm going to square both numbers. So their area ratio would be 4 to 9. Okay, 7a. In problem 6, if the smaller square's area is 28, find the larger square's area. Okay, and so the area ratio from the previous problem was 4 to 9, so that's what I'm going to use. So 4 over 9 equals, and it's asking me to find the larger square's area. Okay, so out of 4 and 9, I'm going to say, okay, well, 9's bigger, so that's where my x is going to go because that's the bigger one. And the smaller was 28. And so now if you cross multiply and divide, you get x as 63. And that would be units squared. Again, if you were to accidentally put the x in the wrong place there, that's okay because hopefully you would realize that you've got a smaller number instead of a bigger number, so you'd be able to catch yourself. B says in problem 6, if the smaller perimeter is 50, find the larger perimeter. Okay, and so here's our perimeter ratio of 2 to 3. So I'm going to say 2/3 equals, and they're wanting me to find the larger perimeter, so I'm going to put an X on the bottom with a 3, because that's my bigger number, and 50 goes up top. And then if you cross multiply, you get X as 75. Okay, last slide, and this one's pretty simple. This is talking about non-proportional dimensional change. What we have been looking at is proportional dimensional change, which means that the dimensions of all the sides are doing the same thing. All the pieces are doing the same thing. They're all being doubled, or they're all being tripled. This is non-proportional dimensional change, which means not all the dimensions are changing by the same scale factor. So maybe just the length was doubled, or just the height was doubled. Okay, and so in this first example, it says double the height of the trapezoid, and I'll show you what happens. And so if you were to get the area of this first trapezoid, you would get, I'll save you the time, it would be 36. If you were to get the area of the second trapezoid, you would get 72. Okay, and so look what happened when just the height, okay, so not the bases, just the height was doubled, then the area was just doubled. Okay, kind of like what we saw with perimeter earlier. So if just one dimension is changing, the effect on the area is just going to be the effect that happened on that dimension. So if the height was tripled, your area is tripled. So that's what number 8 says. By what factor does an area change if only the length of a rectangle is being tripled? So if the length only is being tripled, then the area is also just being tripled. So the scale factor, by what factor does the area change? It changes by a factor of 3.